Hello, everyone. Welcome to my channel, Vikash Lecture on Pharmacy. In this lecture I'll discuss on unit operations. And under the unit operations I'll discuss the topic mixing. Now, what is mixing? Basically, mixing means putting together different substances in one mass. Mixing is the very important and most widely used unit operation in pharmacy. Now, let's see the objectives of mixing. The main objective of mixing is to form a uniform mixture, and second is to bring a physical change, and for the preparation of pharmaceutical dosage form. Let's discuss about types of mixtures. 3 types of mixtures are there: positive mixture, negative mixture, and neutral mixture. First one is positive mixture. When 2 or more miscible solids or liquids are mixed together and form a new mixture, they are called a positive mixture. Those mixtures do not face any problem during mixing. Those mixtures are irreversible, or the substances cannot be separated after mixing. One example is syrup. Next one is negative mixture. When 2 or more immiscible liquids are mixed forcefully, as well as when insoluble solids are mixed with water forcefully. For the preparation of those mixtures, some extra energy or any other materials are required. Those mixtures are reversible, meaning individual mixing substances can easily be separated. Some examples are emulsion, suspension. Next one is neutral mixture. When substances do not have any tendency to mix with each other immediately, but once mixed, they cannot be separated. One big example is paste. Do you know the factors which can affect mixing? Number 1 is particle size. Always uniform-sized particles are needed for perfect mixing. Different particle sizes lead to ununiform mixing. Next one is particle shape. Particles with same shape produce homogeneous mixture and different particle shapes produce heterogeneous mixtures. Number 3 is the particle's intermolecular attraction. Mixing depends on the intermolecular attraction between the molecules of the substances to be mixed. More intermolecular attraction force results in good mixing, and less or no intermolecular attraction force results in bad mixing. And the final one is materials density. Substances with different densities tend to separate into layers. Heavier or more dense material settles at the bottom while lighter substance stays on top. Now, what are the mechanisms of mixing? Mainly 4 mechanisms are there: bulk transport, turbulent flow, laminar flow, and molecular diffusion. First one is bulk transport. Movement of a relatively large portion of material being mixed from one location to another in a system. Here is the simple circulation of the materials to form a mixture. And the mixing is done by paddles or blades. Next one is turbulent mixing. This mixing is the result of turbulent flow. Turbulent flow is characterized by random fluctuation of the fluid velocity, and random changing of the liquid velocity is called turbulence. Next, laminar mixing. By using this mechanism, mainly viscous liquids are mixed. Laminar flow happens when the stirring is relatively gentle. The velocity of the liquid in every place remains the same. That's why it is called laminar flow. And the final one is molecular diffusion. The primary mechanism which is very much responsible for the mixing at the molecular level is diffusion. In molecular diffusion, molecules move from higher concentration to lower concentration, and also this movement is called Brownian movement. And the difference between the concentration is called concentration gradient. Now, let's discuss about Fick's law of diffusion. This law was proposed by German physiologist Adolf Eugen Fick. The law is, the rate of diffusion of a substance across unit area is proportional to the concentration gradient. dm by dt is proportional with dc by dx, where dm by dt is the rate of diffusion and dc by dx is the concentration gradient. Now, let's discuss about the equipment used for mixing in pharmacies. First one is double cone blender. This blender is mainly used for mixing powders of different densities. Blender is made up of stainless steel. Capacity can be from 5 kg to 200 kg, depending on the material volume. Rotation range of the blender is 30 to 100 revolutions per minute. The double cone vessel is also called a tumbler, and the rotation of the tumbler depends on its size as well as the nature of the material to be mixed. Next one is a turbine mixer. This is the most common instrument used in industries for liquid mixing. The machine consists of a circular disc to which a number of short blades are attached. Those blades may be straight or curved. It rotates from 50 to 200 revolutions per minute depending on the nature of the materials. Third one is triple roller mill. This mill consists of 3 rollers which are made up of stainless steel. Rollers are attached very close to each other. The material passes through 2 narrow gaps or nips between 3 rollers. The scraper is attached to the last roller, which helps to remove the mixed materials. Mainly ointment bases are mixed in this machine. Finally, the last one is syllabus and mixer homogenizer. The machine consists of an emulsifying head where blades are attached. Those blades are surrounded by a sieve made up of stainless steel. Blades rotate at very high RPM. The machine is mainly used for the preparation of emulsion. Now, it's time to conclude the lecture. I hope you have enjoyed the whole lecture. Thank you for watching.
Please like, comment, and subscribe.